The broadcast is now starting. All attendees are in listen-only mode.
Yes, good afternoon, ladies and gentlemen. Thank you very much for our webinar session, Festo applications in the aluminium industry. We had a small hiccup where I was still unmuted, but I hope everybody can hear me clearly. My name is Christian van Bokstel, and we would like to have this opportunity today with you to go over the applications and the technologies Festo can provide for the aluminium industry. We would like to provide you a comprehensive overview about the products and services we can provide. So we will not really go into a detailed product level, but our main objective is to give you a good overview how Festo can support you as a partner for your day-to-day business. I'm calling in today from Dubai. Together with me is my colleague, Mr. Nizar. He's also supporting us. He's in the chat. And if you have any type of questions, of course, please feel free throughout the presentation to place them in the chat. Just for the people who are not that familiar with the portfolio of GoToWebinar, we have a small checkbox on the right side of your screen. There's a special tab where you can place your questions, and we will try to answer those during the session, otherwise behind. We hope that the audio is all clear. And we also would like to see if you have any questions regarding the presentations. At the end of today's session, we will be sharing these with you in a digital PDF copy. To start, for those people who are familiar with Festo, we would like to position ourselves briefly where we are focused and how Festo is approaching this industry segment, but moreover, the concept of industrial automation. The majority of our activities of Festo are focused on factory automation, where our main topics are concerned on the control part as well as the motion. We can think about the movement and the motion of pneumatic or electric equipment for handling applications, manufacturing facilities. This is the biggest share of Festo, and a big part of our portfolio is all addressed to this industry segment. Besides this, we also have a second industry segment, which we consider process automation. Still, we focus on the control level, but besides the control level, also we focus ourselves on processes. These can be called gaseous, liquids, solids, or medias. And they can be different from the typical applications we see in factory automation. And for doing and addressing these applications, we considered our process automation pillar, where we have dedicated products, teams, and resources where we support to handle these applications, as we in many cases see that standard factory automation components are not always 100% suitable to use in process automation conditions. To highlight this, and this is more on a component and product level, there's a third pillar of Festo, and a lot of people typically in the industry, they are familiar with this, and this is our didactic services. Our didactic services, we focus on training and consulting, but also on learning systems to get an understanding and a feeling about the possibilities with pneumatics, but also how to implement certain and new trends and technologies within your organization. We start with schools on a young level, but also on a higher level, or within organizations and companies, we provide these services because we see a continuous trend of industries and the technologies developing, especially these days with topics like Industry 4.0, digitalizations, and IoT. Also, we consider these webinar sessions a part of our didactic services on a very light level, because we try to target and address a large audience. But we want to share also the knowledge, and not only talking about items, but also to see how we can improve, how can we develop your organization for the future. Just before, we mentioned about process automation, and one of the topics of today will be aluminium processing and mineral processing and aluminium industries. So you see, we have made a differentiation between a lot of different industry segments. So the reason why we show this is that the more we go to the right-hand side, we are looking into the process industries. And the reason why we make a differentiation is that typically there is one product which fits a lot of applications, but they not always are the right ones, or they need to be tweaked a little bit. So for example, a water and wastewater technology division of us is something different than how we treat applications in the chemical or oil and gas. Or for today's session, and we will gonna deep dive a little bit more into today's topic, will be of course the aluminium industry. So the topic for today's session for our webinar, already shared with you in our invitation, but I want to summarize today, is that the benefits of pneumatic automation. We will have some topics. Then pneumatic automation in aluminium smelting. So that think already one part is crust breaking, but we will add up this a little bit more in new trends. Then the use of control cabinet technology, the topic of digitalization in the facility, and last but not least, energy saving and services. Benefits of pneumatic automation for the aluminium industry. So pneumatic automation is already for a long time present in the industry. And we as Festo, we are we started the pneumatic automation since 1925 in Europe. So we are one of the founders of the technology these days. And we see a continuously trend about the use of pneumatic automation. But the reasons why we see that pneumatic automation is still very high used into the aluminium industry has a few topics and we would like to highlight it. First of all, we see that the automation typically has a direct impact on the performance or the reliability of a process. So a proven technology is a must. And the reason for that is every time when there is a standstill or we are going to have a delay, situations will cost money, but also sometimes more worse, they can create a dangerous situation. And the industry we are active in is quite easy to have these situations occurring. So therefore, a proven technology with a high reliability is key. Besides that, at the same time, and these typically goes hand in hand as well, is also a cost-effective process. So at the same time, we are working on reliability and enhance the performance, but at the same time, we want to do that against the lowest possible cost. And this is where pneumatic automation also provides a really good benefit, especially when there's a high density of products combined in a center where we can combine certain functions in, for example, later on we'll explain control cabinets. One of the good benefits, and it also falls back to reliability, but also on the conditions you're working in, are the sensitive to power failure. This is typically not the one, but dusty and corrosive conditions are something which is, of course, very easily achieved. Think about the rod shops or, for example, the smelting of alumina powder. These are very high corrosive environments where the equipment needs to survive in for a long period of time because it will reduce the interval of products. Then, of course, the long period of time in high temperature environments with strong magnetic fields. Because pneumatic components by default do not have too many electric components, so the use of the impact of magnetic fields are minimum. Also, there's no heat generation by the components itself. Typically, even pneumatics can have the possibility to kill themselves a little bit. So also this is some still application where we see a strong impact of the benefits of pneumatics. Controlled operation. So for example, when it comes to valves, even slow or fast operation can easily be achieved. We don't need to have a very detailed and comprehensive control system. Even with very basic components, we can easily achieve the control speed of a certain product. And this is a trend, and the topic number 5 is where we see the implementation for smart digitalization. So these days, there's a big drive to make industries and facilities more digitalized, smarter. This doesn't mean that they are dumb at the moment, but it means that we need to collect, and we are also capable to collect more information from the field. Although in the past, when we were looking into standard pneumatics with solenoid valves and pneumatic cylinders, this was typically not possible. Nowadays, with smart pneumatics, and we have some really nice applications, which we also will share with you during this presentation, is that we can actually obtain a lot of information from the facility And this will help you to bring you closer or also get an understanding about the life cycle of certain components and to predefined or pre-scheduled maintenance before a product starts to fail. Then, of course, and we always start, typically also in technical universities, always with it's an easy, accessible technology. So even when you're not that skilled, a lot of people can work very well with pneumatics because it's the concept of it. It's not working with a lot of high voltages or complex control systems or programming that is needed. Last but not least, and this is where we see the benefits of pneumatics, is the TOTEX. And the TOTEX is a mixture between the CAPEX, as we see, and the operational cost. There's more than only the upfront investment of a product. There's also the cost which is required to keep a plant running. These two combined, we call it the so-called TOTEX. And as long as this figure is positive, we see this as a really good benefit. So during this presentation, we also like to have it a little bit interactive. So we would like to ask for your opinion as well, or your vision. So we have a pop-up question. This will show up in the screen, and you have the possibility for 3 selections. So please have a look and participate us before we go into the next part of the presentation. Okay, I think we are getting close. We collect all the details. Once we're done, we can complete. So for the people, how do you see the pneumatic automation within your facility? It's well established and it's an easy and reliable technology to work with, option 1. Option 2, I do not see pneumatic automation applications too often in my work. Or number 3, commonly used, but I also see new trends in automation technologies. Okay. I'm not sure if we're going to see the results during the session. Okay, also I shared. Personally, I do not see them because I have my presentation open. But maybe we can, at the end, we can use some time to go over the outcome. I will continue with my presentation. So, the focus topics of today. First of all, we would like to start with the smelting pots. So, for Festo, we have as a portfolio into this are coming from the crust breaker technology, feeder cylinders, as well as the solenoid valves. These originally are quite standard components. However, we increase these with specific features and customized designs. And we at Festo, we developed a special unit for that, starting from 1976, where we provided this technology for crust breaking applications. The benefit, also mentioned before, is we are suitable to handle high temperature for quite long times, as well as the customized designs and the total solution concept. So the way how a crust breaker will be installed in a facility can be in different ways, and we tailor our solutions to these products. In the slide you can see the different features we're providing, but also the point is, and that's where we want to support as well, is that this is part of the TOTEX topic, that it's not only about the upfront investment, also it's about the wear kits. Once the product needs to be replaced or there's wear, we're not going to renew the complete cylinder. We're going to update and improve the components that are necessary, and for that we have wear kits. With Festo and our large service network, not only by our Festo organization, but also our official partners, which we have in each and every country, we are able to support you well and easily, and even also with some online support and training how to deal with our products. So this entire concept also makes sure that it's a total solution from the complete drive, the pneumatic cylinder, as well as the solenoid valve. So we make the combination where we mount all these items combined, and this also ensures us that we can provide a really high service life and a reliability of our products. So when it comes to automation and drives, because crust breaking is one, and typically we see that these are extremely harsh and corrosive environments with customized solutions. Here we see one example of a cylinder with an integrated solenoid, and in this case we use a NAMO interface or an ISO interface where all different types of valve concepts can be used. So also it provides a lot of flexibility, blocking functions, and of course a lot of technical readings and feedback is possible from the cylinder as well to collect this data, eventually also to upload that into a cloud environment to have an active condition monitoring of the cylinders, while maintaining at the same time reduced air consumption as much as possible. Aluminium smelting is one thing. Also, I would like to have this opportunity to highlight some other linear and rotary actuation concepts. For example, if they are looking into penstock application, knife gate valves, or damper applications, we can make these linear cylinders in a modulating version. And here we see a concept of a cylinder with an integrated filter regulator, pressure switches, additional on-off valves, and a positioner with a displacement encoder. So we as Festo, we see these products commonly used, and these are all individual components put together with individual fittings. And in the industry, we see that typically these topics create, or these components create, the possibility for leakages. It's really difficult to maintain because you have a lot of different interfaces and products that need to be replaced in case they are filled out. For this concept, we as Festo, we also want to introduce, and this is quite revolutionary at the moment, our Festo V-top concept. So if you take the same cylinder, which is a modulating linear design, we integrate it with a more clean and total solution of integration. So here we see the cylinder, which is configurable in terms of bore sizes, but also the length of the cylinder. And here you do not see, for example, the integration of the displacement encoder, because we integrated this into the cylinder. This signal is communicated with the positioner on this side, but where there's a big difference from the previous design till now is that the filter regulator, any type of booster functions, fail-safe functions, or even emergency shutdown applications are integrated in our V-top concept. So instead of having a lot of interconnecting tubing with individual components, we have a modular system which can be designed per your requirements and make a total package, and with only one air connection and electrical connection for the positioner. We do not only do this for linear applications, also this is something we do for the quarter turn applications. Benefit of that is one component, modular, configurable, but the main reason also is we cut out a lot of the auxiliary systems and additional tubing, which requires a lot of cost, but also a lot of maintenance in between. An additional technology also we would like to highlight for today's session is the use of control cabinet technology. So in the control cabinet technology, where with pneumatics, there's always an electrical system and there's a pneumatic system that needs to be integrated. And these two work together to make a system operational. If we come from the up DCS SCADA system, we introduce a concept which is called valve terminal technology. These valve terminals, they communicate over a field bus. So instead of going with individual cables into the field, we only have a single cable. This can be different types, Profibus, Profinet, Modbus, TCP/IP, for example. And we have an electrical section where we can connect analog signals, but also the digital inputs 4 to 20 milliamps in an analog, or 24 volts DC for a proximity switch, for example. But at the same time, we're not looking also at two digital outputs. Also, there's a pneumatic section where with tubing, we go directly to the pneumatic components. And no matter if it's rotary applications or linear applications, we can automate all of these items at the same time. So when it comes to the control cabinet technology, this is typically how a centralized control system looks like, with the control cabinets on one side, with a lot of cabling and wiring into the plant, going into a main centralized system. This is typically done when it comes to pneumatic automation with Namo valves, for example, and where you have local termination boxes within the field where the connection is made for the limit switch boxes and the Namo solenoid valves. This is not a wrong technology, but we typically see this for very small installations, but also, for example, in installations where there's a high requirement for ATEX or SIL, for example, where we need to rely on the reliability of the wiring, for example. And of course, it's important to have a certain interface within the plant, so you always know that it's easy to interchange and exchange products. Knowledge level of maintenance staff can be a little bit less because we are only dealing with components, with basics, connections, and integration. An alternative technology we see nowadays much more, also with the trend of digitalization, is the decentralized control system. So instead of having a lot of wiring going into the field, we use still one circular network for the compressed air supply, but we only see also that the electrical circuit is much smaller, where we only use field bus communication to have individual hubs within the field communicating with the control cabinet. And this supports us, and it reduces the cable length and installation time on site. Also, the number of I/O cards in the main control cabinets can be much less because we all communicate over a field bus. Manual override, or also the personal override for people, this can be much more improved because instead of having each and every override on a valve, the solenoid valve, and we can now do this through the cabinet where there are some features for manual control. Upgrades can be made easily because it's a modular concept and it's easy to add or remove components. And we can add additional features like hot swap, for instance, where a solenoid valve can be replaced while the remaining system is still in operation. Especially for critical applications or where the impact of taking down a full system has a big impact, these type of features will add a lot of cost for the maintenance team to speed up their process, and it's like a quick run in, run out to replace a product or a component. As well as the same, and all the I/O functions are shared over the same platform, so there's not a differentiation between a breakup where the I/O needs to convert to a solenoid valve and then this is only a signal. This is all communicated, and the benefit is that we are also having the possibility to run diagnostics up to the level of the solenoid valve, which gives a much better reading out of the status without going directly to the facility. Actually, we have the possibility to highlight and give a signal that a certain product is failed and it needs to be replaced. So making the split from more like a centralized control system, sometimes you can also call it a little bit analog, into more like a digitalized control system. The benefits with this is that we are able also to improve our drive for digitalization. So this also will be our next topic of the session of today. So with digitalization, nowadays we get a lot of terminology like cloud computing, edge computing, but this is nothing more than collecting data and bring this available to a lot of different users throughout a network. And with Festo, we have currently a portfolio where we are having new components which are collecting data from the field or even digital programmable. We have a gateway which communicates through systems, for example, like Microsoft Azure or through an AMQP network. This data can eventually be shared through third-party clouds or directly in case it cannot be shared throughout the network or the system of the client. So we consider this for our main components because for the valve terminal technology, this is commonly used to control components. We do this and we have this system available for our flow and pressure measurement of compressed air to get a feeling about the reading and the usage to optimize plants. And the latest technology is programmable pneumatics. So for the people who are familiar with it, we don't have a fixed solenoid valve function. Actually, we are able to configure the function of the solenoid valve. What type of benefits does this give? We give remote access to these products and understand what the status is and what is the situation of my devices. We can have boarding and scanning. This means that it's the actual process look into the product and scan the devices, and of course, without having this with complicated configurations or software, so make it easy and accessible for the team. We have dashboards developed, pre-developed dashboards as Festo, but also we're already running AI these days over our components, and we compare it with known information, but also the collected information we see on sites, and we can make recommendations based on the trends we are seeing. To start with, and this is number one, is the programmable pneumatics. So in the old days, we were having fixed solenoid valve functions, 3x2, 5x2, 5x3, bistable, monostable. So these were a lot of selections with also a lot of components required in the field. Nowadays, with digitalized pneumatics, where we can actually program apps into a valve terminal, the same concept as we just saw before, where the pneumatic functions are centralized, we can select the valve function. So the same component can be a 3x2 valve or a 5x2 valve, for example, without changing it. Also, we can monitor, and there are more sensors integrated in our components. So, for example, we can detect leakages over a component. We can select a certain pressure level so that not all the components are running on the same level and are a little bit over-designed. We can more tweak this and have more safety in the system. We can control flow, for example. So it has also an impact on the speed of the product is running. And where normally, or sometimes there are additional components required to softly stop a certain item, we can actually program this like a VFD function, for example, on a motor, but now on the pneumatics, so that the startup of a cylinder, for example, goes faster in the beginning, but after time it slows down a little bit. So positioning, also these are applications where we can fix a certain position of the pneumatic drive which is installed in the field. And this is all without having additional products. It's all about software that can be programmed into the specific product. Currently, these are the main applications we're having for our pneumatics. More to come, but this is something in the next session. If you want to know more about this, please let us know in the chat and we can follow up with you. Another part is our energy saving unit, and this is a module which measures flow and pressure. And we can detect the usage of a machine, but also, for example, leakages over time. And together, combined with a dashboard, we can upload this information to a higher level or to a maintenance team. So we can, certain sections of a plant, we can highlight and indicate if there's a leakage happening, and we can steer, or you can steer your maintenance team to take corrective actions to solve this. Also, for example, we can shut off, because this product is having an on-off valve integrated, the device, which will be triggered by the PLC after a certain time when the machine is not being used. In the meantime, the air supply to this machine is stopped, and this way we can save energy and also avoid risky situations because the system is unnecessarily pressurized. Last but not least, and this is more on the valve terminal technology, where we also make use of the dashboards, is an example where we have an angle feed valve where we use with our proximity switch at the rear side of the valve the status of the valve seating. And we were able to detect the opening difference between 0.01 millimeters. And for this process where it absolutely was required that the valve was fully closed, we could detect the status of the valve. So a part of predictive maintenance can be integrated in all standard components, but because of the platform and the available dashboards that can communicate through the cloud, we can make this information easily available to your team. Also, you can think about, for example, about the usage of pneumatic valves. Do you know, for example, how often does a pneumatic solenoid valve switched or operated, or a valve maybe? This displays and these dashboards will give you a direct figure about the performance of it, but also the expectations when the product might be failing. With the mean time to failure rates, for example, of a solenoid valve, we can predict how far in its life cycle the product is and what can we expect for the short-term functions. This is all available and ready to share through communication. But when it comes to digitalization, it's not only products. Also, we have been pushing a little bit of products. Our apologies for this. But it's also software tools. So nowadays, for example, when it comes to the control cabinets, we have configurators in place. Process valve assemblies can be configured online. So this is something also for an engineering team which is wants to have a quick understanding how a certain product or solution will work. We provide tools ready available that can be implemented. We do not only provide the selection and the components with the part list, also we provide the implementation of 3D drawings which can be integrated in a BIM model, for example. So you can easily forecast and predict already the right components for certain applications. These tools, in combination with the configurators as well as the 3D drawings, which are already available as we speak, these can be used for both valve assemblies as well as control cabinets. Make it easy to shorten the time of design up to final solution. This doesn't mean that, for example, we provide all, or we ask our clients to do all the engineering themselves, but we already provide tools so we can already push a little bit in the right direction. The customer and yourself can look into the possible solutions you might see for your applications. So when it comes to the support and the technical recommendations and the experience we want to share with you, we can shorten the time of the basic items, and we can already focus our time more into the more important topics. So this saves time, so cost, of course, because also man hours and time of your team is, of course, having a value behind. So this is the combination of our digitalization. We also need to think a little bit outside the box, not only components, also the tools we are able to provide with you and to provide easy calculations and get these tools. And with Festo, we always believe in sharing this information. So this is all free available without any portals or registrations, just to start directly after the session, if you like. Then it comes, last topic of today's session is energy saving and services. So compressed air, and as an inventor or the driver for pneumatic automation within Europe, we see that also it's not about the components, and also it's about the use of compressed air. And for example, when we take a 15-year life cycle of a compressor, we see that roughly 75% of its total cost is used in energy consumption. Especially for aluminium industry, I believe this number will be much, much higher. So therefore, it's very important that we look into the usage of quick, but also clever uses of this compressed air. There where we can reduce it, we should definitely do that. But at the end, it's all about the carbon footprint that we are achieving together. And for compressed air, this can be achieved by a so-called the ISO 11011. It's part of the ISO energy management, the 50001. And for Festo, we classified 3 topics, which means the air consumption analysis, typically number 1. But it's also about air quality and the leak detection, how to identify these systems and these leakages. So the benefits, of course, for Festo is that as a component supplier, we are an independent advisor. We are not tied up or bound up with certain compressor manufacturers. We only look into the information and the details and the data we receive from site. We are one of the few companies in the world which are TÜV certified to conduct ISO 11011 audits and to provide recommendations how to optimize. And for you as an end user, we provide portals and leakage management tools, all with the idea, and also for this week we have the sustainability topic, that we reduce energy and of course the carbon footprint reduction. How do we do this? So this was, of course, the topic where we consider 5 levels. Typically we start from an intake, and we have some planning, execution improvement, and the highest level will be maintenance and condition monitoring. And the basis of the intake is that if you have a big plant with a lot of items, how are you going to approach this? And typically we work with audits or pre-audits with the philosophy of the ISO 11011. And for example, if you have a plant, it's not fully the same as in the aluminium industry, but we use this picture for many applications. We highlight the different zones. So number 1 is the energy analysis of the compressed air generation. Typically, these are the compressors. But also the air quality that has been generated. So for example, how much dust, particles or oil is blown into the air network. At the end, these three parameters are having an impact on the life cycle of a pneumatic component. The better the air is, of course, the longer the pneumatic component will run. At the same time, the cleaner the air is, the higher the cost will be. And also we would like to reduce this. Another topic is pressure drop measurement. So it's very important that a network and also the components are well sized so that there's the right tubing diameters going to and from each network. If the pressure drop is too high, you see this as a losses. See it as a highway where too many cars need to go through the same line. So the more pressure drop we have, the more leakage we are having. And typically with compressed air, you don't always see this in a direct problem. So therefore we are able to allocate these locations by doing actual measurements in the system without interfering the process. Then of course, the machine optimization and also the consumption analysis on the machine side. So on one side we have the generation and the other side, of course, what is consumed inside. Number 5 is the leak detection. Also, how many leakages are there, and more important, how are they monitored and managed. So, for example, with Festo, we use specific dashboards, and also within a facility, these are typically one of the major benefits that can be achieved by running such an audit. When a line or a water line is leaking, then this always gets direct attention. When air is leaking, sometimes it's not well heard. Also, sometimes it's not seen. So, and it's of course also not creating a direct problem. So that's why we always want to optimize this as well, and we look into this topic. And of course, the machine analysis. So sometimes machines have been built many years back. There are new products, new ideas, and technologies that can be used to use air or compressed air in a more effective way. There are in total 12 measures we can implement. Typically, it differs case by case, but we use these as a guidance to look into each and every application. And of course, we start with the biggest factors first. But when it starts, and this is something where we work on the pre-audit, it's not we walk in and we provide a small report. We do this very thoroughly. So we, as per the ISO 11011 standards, we need to consider certain standards to comply with when we do such an audit. The audit is completely independent, so there's no direct benefit for Festo to provide certain recommendations. And also, by the German TÜV, we are measured on this so that our reports are being checked, so that we are completely independent, standalone partner to guide you on this achievement. Of course, prioritize and optimizations and measures, so where to start first. And for this, we have certain graphs on component levels where we see this is where the first attention needs to be placed, so we have the quick wins easily achieved. And of course, we can make a plan with you how to approach that. And of course, and this is something with Festo, we are complying with the energy management systems. That means that our reporting can be directly implemented if you already have an energy management system like the ISO 50001. And this all comes with the Festo certificate from the TÜV. So, and this is every year renewed. We need to do a lot of efforts for that. So it's not something that everybody can do. We have certain equipment for that, a special team that is able to go much more detailed in this topic with you. So in a nutshell, and we have a lot of topics covered already today, we would like to ask for your participation again. We have another pop-up question, which I would like to raise in the next slide. So I ask my colleague to start up with the poll. For the question of this moment is, we use an attractive system to reduce and optimize use of compressed air on a regular basis. So are you using any type of system at your facility to look and to identify the reduction of compressed air? So questions, and your answer can be, no, we are not really having a system in place to monitor and register this. Yes, we work very actively to reduce compressed air usage. Or this topic is completely new to us, and I'm interested in the possibilities and benefits what it can have for our facility. I'm looking forward for your support and your feedback. I will ask my colleague, Nizar, can you start the poll? I'm not sure, maybe we...
Christian, yes, it's already started.
Okay, I don't see the message. So
yeah,
that's,
these are already voting. We
really
have
good.
55% voted for this poll question.
Really good. Can you make the summary of this, Nizar? Because I don't see the screen in my my view. So maybe it's nice with the attendees to go over the feedback.
Sure.
Question.
So sharing the results of the poll question, 33% answered we don't use a system to reduce compressed air usage. 50% yes, we work actively to reduce compressed air usage, and 17% were voted on that the topic is very interesting and it's new for them.
Really good, really good. So for sure, we are really happy to see that there's a big drive and of course a focus to reduce compressed air. So we're happy to see the 50%. The 7%, of course, we are always looking to share and discuss these topics with you and also go a little bit more into detail. Of course, for the remaining 43%, which are not really having a system in place, I hope this presentation and this soft introduction is a nice introduction to you to start up the discussions and maybe to explain a little bit more how you can benefit from systems like this. So, okay, I think we can move to the next question. Next slide, I believe, right? Then.
Yes. Yes.
For the summary of today's session, also we are almost close till the end, is the topics we covered today. The first number one is the benefits of pneumatic automation. How can pneumatic automation be effectively used in the aluminium industry? I think we answered this question because it's very effective in terms of technologies that can be offered, suitable for harsh environments against very good costing. And also, of course, it's simple technology. Also, this was one of the feedbacks we received from the very first poll question. And while there are, of course, new technologies being implemented, still we see that this technology has been really well established still and has a good future. Of course, pneumatic automation for aluminium smelting, harsh environment conditions, and with, for example, crust breaker applications, feeder cylinders and idle solenoids, but also the new technologies which are going to get in place. For example, the VTOP model we showed with you, where we have a modular concept to integrate several functions into one item without having additional equipment around it. The concept of control cabinet technology, an effective solution to centralize pneumatic, protect it from the environment, give more support, also an easier situation for your team, your maintenance team to work with. At the same time, collect more digital signals, communicate over a field bus, and already make a step to the digitalization topic. And then, of course, digitalization, they improve the connectivity and collect data from the field. More data for what we've been using before. And that was also what, where sometimes in the trends in automation technology, pneumatics could have been considered as an analog technology, but actually now with the new digitalization products and the technologies that are available, pneumatic cannot be considered any longer as an analog technology. It's fully digital, it uses the same standards, and there's much more information and details that can be obtained through this, through implementing new products. And combined with the focus on the TOTEX of an installation, CAPEX cost can be still reduced while having a reliable installation. Last but not least, to end up on the topics discussed, the energy saving services, the importance of using compressed air well, and of course to extend the performance by monitoring and setting standards. So you can imagine then when air quality is improved at the facility, of course this will extend the life cycle of your facility. combined with the digitalization tools, we can also make this visible. We can show the numbers also to, for example, management. And of course, we are also working on to get our facilities more sustainable and reduce on our carbon footprint. So for the last participation on your side, we would like to have one more pop-up questions, and then we will close the session of today. And we are very interested to get your feedback. You can select more topics than just one. What is the most interesting topic for you today? Our Festo crust breaker portfolio for the smelter applications, the additional linear or rotary automation technology, the VTOP concept we just mentioned, control cabinet technology and the possibilities which we can achieve, energy saving, or thank you very much, Festo, but all the topics of today were not really mentioned. So if you can share your opinion, that would be highly appreciated. So also we know how we can help you better in the future. We're really happy to have a very nice audience, and we're looking forward to help you even better in future sessions to come. I think, Nizar, you are having a close eye on the participation and the feedback we are getting from the system.
Yes, thank you, Christian. I'm now sharing the results of the voting on the poll question. 38% were, let's say, decided or selected the crust breakers. 54% are interested in linear or rotary automation technology, VTOP. 46% are interested in control cabinet technology, and 38% are interested in energy saving and services to reduce compressed air usage. 0% voted for none of the topics mentioned in today's session. So we are lucky to have this percentage.
Excellent. And also we're happy that we are able to contribute to today's topic. I believe we have now also quite some work with you to do. So also, of course, we will follow up. We will start to share our presentation with you. Last but not least, in case there are some questions from your side, we haven't seen them in the chat so far. So maybe I think we definitely will get some more questions when we are sharing maybe some more information with you. If you have, of course, please feel free to share them. But at the same time, also, you can always visit us. We are locally here in Dubai and in Jordan. We have our website. Always recommend to start following us on LinkedIn. In the topic of digitalization, this QR code is working and direct you straight to our page. Also, we upload a lot of pictures and videos on YouTube. And of course, always feel free to share us an email. We will thank you really much for today's participation. We are looking also forward to pick up these topics. We have a really good feedback on what we've mentioned and introduced today. So we will get back to you shortly, and we would really like to thank you for spending this time with us, and then wish you a really good day. Thank you, and hope to see you soon after all the measures and we are able to travel again. Thank you, bye-bye, and see you next time.